Again, as a friendly reminder, today we are talking about things that it's not difficult, okay? It's just kind of annoying in terms of what we have to do. And that is we are going to be getting started and discussing significant figures, okay? The reason why, who can tell me or refresh me why we talk about significant figures? That is a good, there it is. We really only use it in scenarios where we are measuring things. So a lot of that, science class. Remember my example talked about measuring the area of the room? One way we're using a ruler, the other way we're using a laser sight. Okay. And we said the laser sight's going to be more precise and accurate. Both of those are going to be precise and accurate, more so than the ruler. It's going to give us, as close to the exact values we can in on a consistent basis. But if we were to use the measurements of the laser and the ruler together to measure the area of this room, we could only report our answer to a certainty. Okay? When we talk about Sig Figs, we talk about levels of certainty. Okay? And it comes with a level of understanding that, okay, I didn't use the most precise or accurate instrument to make one of my measurements. So unfortunately, you can only measure to the or report your answer to the degree of your least accurate equipment. Okay? And so, we're going to see it from time to time, more so when we're doing the math aspect of it. But for today and tomorrow, we are simply going to focus on how we identify what numbers are significant and what are not, and how we go about rounding them. So the most of our focus today is going to be looking at a set of rules you've got to stick to, and then we're going to be doing some practice before we call it a day. No homework this evening, okay? Tomorrow, we're going to come in, and I've got something set up for you to take stuff from today to work on, all right? But no homework this evening. What you want to do is get your notes out. You do not need a calculator today. Not until next week. So as you're getting your notes out, I mentioned that we are going to be going over a series of steps. Now, when it comes to rounding, there are a couple of rules that I'm simply going to discuss just so I say I discussed them, but we are not going to really utilize them in here, okay? And the reason why I say that is because in regards to those particular rules that I'm talking about that we're not going to necessarily utilize, in the other two classes that I teach, physics and honors chem, between those two books, they give you slightly different rules and guidelines on how to do significant figures. So it really depends on what and where you get your guidelines from, is what you should really go by. Now, just a quick story before we get into this. Okay, I teach Sig Figs in every one of my classes. Okay, every one, and there's a reason why. I got an email last year, and I've gotten a couple of emails over the years from students who got off to college, were in either chemistry or some other science class, and they came to the topic of Sig Figs. Guess how many students in that college kids classroom knew how to do Sig Figs or even knew what they were.
Yeah.
So he was mentoring and tutoring his classmates in college on Sig Figs. Because when you get into, or if your path is to take science in college, or even if sometimes you're not going to, but you have to take some as a prereq, they get somewhat hardcore, okay, in terms of Sig Figs. It's very important to them. Because like I said, there is a reason for Sig Figs. It's just kind of an annoyance, okay? Let's get into that annoyance right now. The basis of significant digits, they are based upon the precision of available tools used for making measurements in the lab. And much like my use of the ruler and the laser to make measurements, oftentimes the precision is limited by the tools available. We don't have a laser measuring device here. At least I don't know. So we are going to be stuck with using very basic measuring tools if we wanted to measure the area of this room. Some examples that you might see. For instance, we've got one of the examples right up here. A digital clock. You know, a lot of the clocks on your watch, on your phone, or even at home on your nightstand. The digital clock is going to be less precise than an analog clock. This is an analog clock, one with hands. Okay? Because the digital clock, you only display the time in terms of minutes and hours. Actually, you do it to the nearest minute. With an analog clock like this, you're actually getting even more precise. You're getting to the nearest second. So you're getting into smaller fragments of time using an analog clock, so you can have a more accurate description of what time it is currently. As scientists develop better measuring tools, the more precise the measurements can be. Again, now we go into a stopwatch to be more precisely measured time because it could measure the 10th or 100th of a second. So a stopwatch would be even more so precise than that clock, because we're measuring to smaller and smaller fractions of time, getting closer and closer to the actual time it currently is. So when we measure Sig Figs, okay, significant figures include all known digits plus one estimated digit. We're going to talk about this example up here. Okay, so all known digits and one estimated digit. So if you look at this part right here, okay, see this purple line? We measure it. You see the dashed line connecting it to the ruler where it's measured. We know that 5 centimeters is known. We know that that line crosses at 5 centimeters. Excuse me. We also know that 2/10 of a centimeter is present because it still goes just a hair past the 2/10. So we know up to this point that the length of that purple line is 5.2 centimeters. But again, Sig Figs always include all known digits plus an estimated. So I'm sure you've done this a lot, where you might have something you're measuring and it stops in between these two marks right there, and you kind of guess what it could be. That is your estimated digit. So for this particular instance, 0.3 centimeters is our estimated value. We could have said 0.2 or 0.02, sorry. So overall, we would report this measurement as 5.23 centimeters, with that last digit being our estimated, okay? So when you measure stuff, that's how you go about it, okay? You always write what you know and estimate your last one. Now, rules for counting. Right? Counting, yes, can remember for this counting around it first. These are the base of rules for anything that we do from here on out over the next handful of days or so. You have got to know these coming rules before you can really do anything else. That's why they're first. Rule number 1, non-zero numbers are always significant. Give me an example of a non-zero number. 2, 1, -3. Get it? Those are all non-zero. It's in the word there, non-zero. So all non-zeros are going to be significant. So looking at this number here, 72.3. Is that blank on your page? Because it's a different color. I noticed on my, is that blank? Okay, good. 72.3. How many non-zero numbers are present in that number? There's 3, right? So in the number 72.3, you have 3 significant figures. We start off easy. Not that they're terribly difficult, but that one is A number 1. Rule 2, zeros between non-zero numbers are always significant. So if you have a kind of a number sandwich going on here, a 2002, how many zeros are sandwiched in there, right? So when we have situations to where we have zeros between other non-zero numbers, they are also going to be significant. So the example on here is 60.5. Again, you have that 1 0 that is sandwiched between 2 non-zero numbers. Therefore, it itself is also significant. So again, based off rule 2, 60.5 has 3 Sig Figs. That's what SF stands for, Sig Figs. Rule 3, all final zeros. Now this is important right here. All final zeros to the right of the decimal are significant. I'm going to show you what I'm talking about, why we need to know that. All final zeros to the right of a decimal. The decimal, when talking about Sig Figs, is almighty. It really has a lot of emphasis, or places a lot of emphasis on how we determine what's significant. 6.20. Again, that final zero, because it's at the end, is to the right of a decimal. Again, that has 3 significant figures. Now I ask you this question. What about 4,200? How many? 2. Why do you say 2?
Because there's 2 zeros.
And no decimal, right? Excellent. So,
What if it was what?
go ahead.
42.003.
42.003.
If we have 2 zeros.
All of them.
To the right. So then all the zeros are
Point, you say 42 point or 42,003?
42.
Like that?
Yeah.
How many do you think? Huh?
Would it still be 2?
Mm-mm.
5.
Who said 5? Very good. Here's why. This number actually refers back to rule number 2. Zeros sandwiched in between non-zeros.
So we have 2.
Hmm?
So we have 2 zeros.
You have 2 zeros, but it's sandwiched in between non-zero, non-zero. So we have a total of 5. Now, what if I did this, Hayden? 42.00. 4. Very good. Very good. So yeah, off to a good start. Rule 4. Placeholder zeros are not significant. To remove placeholder zeros, rewrite the number in scientific notation. It's something we spent a good deal of time on not that long ago. So, looking at these 2 examples, 0.0253 and 4320 each only have 3 significant figures. Now let's break each one down. Why does this only have 3 and not 4? Why does 4,320 only have 3 and not 4? Yeah, before decimal or the lack thereof of a decimal, right? So that's why it no get count. But look at this here, 0.0253. There is a 0 to the right of a decimal, but why don't we count that? It's not sandwiched in between there, and I'm going to take a little bit from rule number 3. It's not a final 0. It's not the last number, or you know what I mean? What these act are, that's some rain, are simply placeholders. Now, if you wanted to, I want somebody to tell me what that would be in scientific notation, 0.0253. 10 to the negative second, so 2.53 times 10 to the negative second. Very good. 2.53 times 10 to the negative second, because anytime you move a decimal to the right, negative exponential value. Last rule, and I've got to say something because you're going to be upset with me because I just remembered something. You are going to need your calculator for our examples. Sorry. You can get it. You can wait a second though. Rule 5. Counting numbers and defined constants have an infinite number of significant figures. And this is just thrown in there for fun. I don't even have this rule in my other books, but what they're meaning is when you have 6 molecules, or when you have 60 seconds is equal to a minute, you know, things that are constants in our life, or 60 minutes in an hour, those have infinite Sig Figs. That's just an extra bit of information for you to know. Okay? Your main focus, these first 4. Okay? How do we get to rounding? Calculators do a lot of stuff for us, but they have yet, unless at least the calculators I use, they might have them now. I didn't know that we had rechargeable calculators anymore. Some from the battery age. But calculators are not aware of significant figures. So you have to, what's that? You have to be aware and follow the rules to determine how many sig figs you should round to. And then when we start getting into math, okay, kind of a similar situation. Your answers should not have more significant figures than the original data with the fewest figures, and therefore rounding will and should occur. Okay? Again, it goes back to, you know, between the laser and the ruler. We can only report our answer in terms of the numbers measured from the ruler, because that's my lowest precision instrument. Here's a question. We are to calculate the density of an object whose mass is 22.44 grams and whose volume is 14.2 cubic centimeters. So don't forget, density is equal to mass divided by volume. Now, before we even calculate this, let's first try to find out which one of our values, our measured values, has the smallest number of significant figures, so we can keep in our mind what we have to round to. Okay? So just to put these in here real quick, 22.44 grams over 14.2 cubic centimeters. Which one of my values has the least amount of significant figures? The volume. Let's count. How many significant figures do we have here? 3. Okay, all 3 of those are non-zeros, so they're going to be significant. How many does my mass have? 4. 1, 2, 3, 4. Again, all 4 are non-zeros, therefore they're significant. So when we calculate this, give me the entire answer that you get from your calculator. 1.58028. That's good. That's good. Okay. So you see you get a very long number. Okay? But this is not, we cannot, by rules of Sig Figs, we cannot report our answer that way. We can only report based off of our measured value with the fewest significant figures. So looking at this, can you tell me how this number that I've written, how many significant figures are right there? 6. Very good. Obviously, we're a little off the mark here. So we need to find out what place our third sig fig is. So 1, 2, 3. Right here. That's our third sig fig. We have to think about, do we round? Okay? So you go to the very next number. Basically, growing up, you probably had a system of rounding. 5 and up, you round up. Below 5, you round down. Same thing here. Okay? So basically, how my real answer would look like is density is equal to 1.58 grams per cubic centimeters. Now, just got a brief few rules that we're going to talk about in terms of rounding. It basically reiterates it, but I still want to go over it. Okay. Rule 1. If the digit to the right of the last significant figure is less than 5, do not change that last significant figure, meaning do not round it up. Rule 2 goes along those same lines. If the digit to the right of the last significant figure is greater than 5, round up to the last significant figure. Then you might ask yourself, what if my last figure is 5? Okay? I mean, usually we do 5 and up is up, and that's what we're going to do. Okay? We are going to do 5 and up, below 5, round down. These rules 3 and 4 are those 2 rules that I was talking about at the very beginning that I just absolutely don't like. Okay? They say if the digits to the right of the last significant figure are a 5 followed by a non-zero digit, round up to the last significant figure. So basically 2.5351, okay? So since we're at 5 right there, and that's a non-zero, we would round up to 2.54. If the digits to the right of the last significant figure are a 5 followed by a 0 or no other number at all, look at the last significant figure. This is my favorite one by far. If it is odd, you're then going to round up. If it is even, then you do not round up. All right. So obviously, 4 is out of the window. It hurts my head just to even read that rule. Okay? So I just wanted to mention, there are rules for when we do have 5 as our last significant figure, what we do then, but we don't bother with it so much. Okay? Now, we're going to get into adding and subtracting later on. What I want to do is, again, would you mind going over to Mr. Hampton's room and asking for the Sig Fig worksheet? Okay. Now I said we're not going to have homework. We are not. I'm simply going to give you a sheet that we're going to go over a handful from kind of each section together. If you wanted to, just for some additional practice, by all means, you can finish what we don't do. Okay. But it is not a homework assignment, but I still want you with me when we are going over these on the board. So we are not done with class yet. Jared passes to the left. Go back to my old method of passing out papers.
There you go.
Madison, there's come your way. Might give one to Jackson. Any extras? I'll be over there in just a second to come get.
Okay. All right, be there. Cool.
John, please.
We weren't lost. We were
Thank you.
you.
Everyone should have one. All right. So everyone should have one. Those of you at home, I posted at the classroom, so if you're still here, then you can see them. I'm going to just do this on the whiteboard here. All right, so let's take a couple of examples. Let's look at under the first one real quick. Number 1, 2804. We are to figure out and state how many sig figs are present. How many we got? So we just simply write 4. Number 3, 5.029. How many we have there? 4. Again, that 0 sandwich between non-zeros. Let's look at 4. 0.003068. Who says 4? Who would like to explain why? Tristan. You were too slow putting your hand down, so. Okay, who, raise your hand if you would like to explain.
There's nothing sandwiching it in, and they're not final zeros.
Okay. So they're just placeholders, right?
Yeah.
So how many, but we still go with 4 because that 0 is sandwiched. Very good. Very good. Now I'm going to throw another one out there. It's not on the sheet. 0.00360. 3. Final 0 to the right of the decimal. Again, that's not on your sheet. I just wanted to add it. And then let's go to 11. 75,000. Oops. 0. Oh, so yours, mine are numbered, and I redid the worksheet in 75,000.0.
No, there's 2. There's 1.0.
Yeah, we're bouncing around a little bit on here. So, do you have any answer? Not 3.
4.
Let's talk about it. Why do you say 6? Aha.
Final 0.
Mm-hmm. So we've got a fancy situation here. 75,000.0. What did I say about decimals? All powerful. By placing that decimal there, having that 0 to the right, there is 1, 2, 3, 4, 5, and 6. Good job, David. One more in this section. 12. Or whatever yours is, it says 10. L, okay. 1. Very good. Since there's no decimal, that final 0, no count. All right, sounds like we're doing pretty good on the identifying. Now let's scooch on down to number 2, where we're going to round to 4 figures. So let's look at the first one here, 3.682417. First off, which one of these numbers is my 4th significant figure? The 2. 1, 2, 3, 4. Okay, so we then look to the number to the right. Is it greater than or less than 5? Less than. So what do we do to the 2 here? Do we change it? No. So your answer would be 3.682. Next number, it's coupled down the line there. 375 point, excuse me, 6523. Which number is my fourth significant? 6. Okay. We have a 5 here. But what are we going to do? What are we going to do to that 6? Round it up. We're going to go up 375.7. All right, now let's drop down to the next section to 1 decimal place. Okay. We're going to hop on over to 2.473. 1 decimal place. Who is my significant figure then? Oh, I didn't even put that right where I wanted to. Yeah, it's 4. Okay. What am I going to do? How am I going to report this? That's a 7, yep. So 2.5. One more, then we'll call it good. Go to the next one, 2 decimal places. 0.00. Oops, sorry. Let me try that again. 0.03062. So who is in my, first of all, when we say 2 decimal places, basically we're talking about the hundredths. Who is in my hundredth spot? Yep. So what am I going to do here? How am I going to answer that? My next number is 0. Am I going to do anything to it? 0.03. How do we feel Sig Figs? Again, they're not terrible. They just become an annoyance, especially when you start getting the calculations and you're so used to putting the actual number that you get from your calculator there. When you follow these guidelines, you have to go back to the problem and check and find out and follow these rules and all that good stuff. Again, this is not homework. Okay, we're gonna do more like this tomorrow, just to make sure after a night's sleep how we process this information. So thank you for joining us at home. I'm stopping recording. I will get